this module, we're going to cover structures, or more commonly referred to as structs. It's a very common type in Swift, so let's get into it. So as we go through structures, I'm going to cover 4 different concepts related to it. 1 is what a structure is. 2, why do we need them? 3, how do we declare them? And 4th, how do we operate on structures? So first of all, consider the following. We want to create a single variable that holds information about books in our home library. We want to print out the number of books in our library, and with each book, we're going to print the title, the author, and the page count for each one. So how would we do this in Swift based on what we know so far? So again, I would prompt the students to work in teams and see if they can come up with a solution. So here is some potential solution that somebody might produce. Basically, we have this variable called a book, and then we've defined it to be basically have these 3 elements. So what this looks like is a dictionary to me. And the reason is because although this would indicate an array, because the elements all have this colon here, here, and here, these are actually key value pairs. So if you go back to the dictionary module, if this is not clear, you'll be able to kind of go through that again and make sure you understand the concept of dictionaries. And what's interesting about this is that we have a key and then we have a value. So here title has a value of Cosmos, which is a string. Here we have author, which is another key. And then here, the author looks like it's an array of strings of first name and last name. And then finally, we have a page count, and it has a number of 485. So a question might be, why is this not a valid solution? So it turns out it's not a valid solution because a dictionary has a key value pair where the key is typically a string, and the value can be any type we want, but it has to be the same type for all of the elements of the dictionary. So for example, we could have a dictionary that has a key of string. These are all the same type. Those are fine. But notice this is a string, this is an array of strings, and this is an int. So since those types are all different, then a dictionary is not really well suited for this because the types of the values of those items are different. And that's pretty key as we think about structs. So here's another possible solution would be to just break up those things into different variables. So we could have a variable called titles, and here we have an array. Now notice we don't see any colons here, and this is just an array of strings. So we have Cosmos here, we have A Brief History of Time as a second book. Authors, we have Carl Sagan and Stephen Hawking. And then third, our page counts, 485 and 372. So does this work? Actually, it does. I mean, it fulfill the question that we had. And basically, we have this for loop that iterates through all of our titles. So it's iterating over the elements here, and these all correspond to the same count, the same number. And then we're printing out title, author, and page count. And so this basically does work. So what happens if we do this? We add in a new book, The Origin of Species, and this book is written by Charles Darwin. So we've added those in, and then we get interrupted, and then we think, okay, we've added this book into our list of all of the books that we have in our library, but we didn't update this page counts down here. So because we didn't update that, we have an array here that has 3 elements in it, another array of 3 elements, and here's an array of 2 elements. And so things don't match. So when we go through this loop here, what do we think will happen? So what will happen is when it gets down here to do the page count, and it looks at page counts with an index of I, which is going from 0, 1, and 2, there is no element 2 in here. And this is going to crash. This is going to cause an exception. So this is not a good solution either. So let's jump into Xcode and kind of see how this looks in Xcode. So we're basically in Xcode, and I'm just in a simple playground. And so what we're going to do is come over here, and I'm actually going to paste in that first set of code that we looked at in the slides. And basically, remember we said this was a dictionary, and it's not a valid dictionary because the types are different here, here, and here. And sure enough, we are getting an error from the compiler saying that this heterogeneous collection literal could only be inferred to be string any. So that's a very obtuse way of really saying that this string type for key is fine, but it can't derive a single type for what this should be because they're all different. And so it's giving us, it's saying I would have to make this what's called the any type. We haven't covered the any type yet. Don't worry about it. The point is it's not a valid dictionary, and that's really not going to work. So let's look at our next solution that we had. So what I'm going to do is I'll take this out and I will paste in the second solution just so you don't have to watch me type it. And now as I've entered that, notice that I don't have any errors anymore. And that's because I have 3 different variables. Each are arrays. This is an array of strings. This is an array of strings. And this is an array of ints. And then here we're iterating through a for loop that's going to go through by counting from 0 up to titles.count. So titles, we're looking at titles and we're looking at the count of how many are there, so 2. So this is going to go 0 and 1, and we should print out these items. So if I were to come down here and click the play button, it's going to run, and we can see right down here, we ran through the 2 books and we printed them just fine. So the next scenario is to say what happens if we go in and we add a 3rd book. So I would come in here and add the new book. We'll call it, let's see, I think it was The Origin of Species. And this one was by Charles Darwin. So I've added a book title and I've added a book author, but I haven't updated the page count. But notice these things aren't really related to each other. The compiler doesn't know that they should all have the same count. So we don't get a compiler error. But if I go to run this, what happens? So we click run, and sure enough, it runs for a while, but then it says index out of range, and we see we have this executed bad instruction, which basically means we crashed. And we crashed because we were indexing an array element that wasn't actually here. So this is really not a good solution. It's not a good solution because any modifications that we make here are potentially error prone, and we can get things out of sync. So there's got to be really a better way to do this. And the better way to do that is to use structures. So let's jump back into the slides and take a look at that. All right, so structures to the rescue. Here is an example of a struct that basically represents what we just went through in a much better way. So let's look at the components of a structure or a struct. First of all, to declare a struct, you're going to start out with the keyword struct. Again, this is very similar to var for variable, func for function. So struct, structure. So it should be easy to remember, and that's how you start it out. The second thing you follow with is the name of it. So just like var with a name or func with a name, struct is going to be followed by a name. Now, the interesting thing about the name for a struct is you're really declaring a new type in Swift, very much like we did with enums for enumerators. And if you don't know what those are, we have a module on that and you should check it out. So the thing about creating new types in Swift is all types start with a capital letter. That's just the convention. So notice here when I say book, I'm giving it a capital B to just visually indicate to somebody who's reading my code, if they just see book, it shows that it's at least a type. They understand that. And then, of course, we create our brackets. So we have an open curly left bracket, a close right bracket, and then everything between those brackets make up the struct itself. And then we can just go ahead and declare variables of all the different elements that we want to produce in our struct. So this is where the dictionary wasn't valid, right? Because the dictionary said that all of these kind of needed to be the same type. In struct, we're not limited to that. So here we have var title, which is of type string. We have var author, which is an array of strings. And then we have var page count, which is an int for integer. And so this is how we can declare a struct. And every one of these, title, author, and page count, are referred to as properties of the struct. So just to reinforce that, title, author, and page count are all referred to as properties. These are properties of the struct. So then the question is, all right, great. So now we have this new type called book. How do we declare a instance of it? How do we actually declare a variable of type book? Well, we can do that right here. We can say var cosmos. So we're just creating a new variable name. We're giving it a type. So we're saying it's colon book. So just like it could be colon int or colon string. And then we actually say you're equal to, and instead of saying you're equal to a simple value like a string or an int, you're equal to the book. And so when we type out book here, we have what's referred to here as an initializer. So this right here is an initializer. And what this does is this will initialize book with the values that we've put here. So for example, you could imply that if I've got title Cosmos here, then the var title is going to get set to Cosmos. Author, I've given it an array, Carl Sagan, so sure enough, that author is going to be set up with that array, and the page count is going to get 485. So when this finishes, Cosmos will be of type book, and title, author, and page count will all be set. So here's title, here's author, and here's page count. So now if we want to access an element of the struct, it's a little different syntax than like we did with dictionaries. It's with the dot notation. So basically what it's saying here is if I want to print out the title associated with Cosmos, I basically print the name of the variable followed by the dot and then followed by the property, right? This is the property here. So when we do that, we end up with Cosmos printing out. So here's another one. So this is the property author. So we're printing cosmos.author, but because it's an array, we have to give it an index. We could just print out the whole array and it would print all the elements, but let's say we're just printing the first one or the first name. We can do author 0 here and we would end up seeing Carl. And then finally, if we want to do page count, we're doing cosmos.page count, and that's referring to this property right here. And remember, it was initialized with that 485, and so now we have printed cosmos.page count. So now let's check this out in Xcode. So the first thing I want to do is basically enter the struct. So let's do that. So I can type in struct book, and we give it an open curly bracket. It gives me a closed bracket automatically and a nice line in between to start typing. And we can enter our first property. So we can say var title is going to be a string. And the second one, var author, is going to be an array of strings. So we put an array as a bracket, left and right bracket with string in between, and now that's an array of strings. And then finally, we can say page count, and we can make that an int. So we now have created a struct called book. It's a type. We haven't declared a variable yet. We have nothing really here to execute, but this is good. We didn't get any compiler errors, and we've created our first structure. So now let's suppose we do want to create that first book called Cosmos. So we can do that by saying var, we give it any variable name we want. I think in the slides we said Cosmos, so we can do that. We want to give it the type, so we can say book. And then we want to initialize it here, so we can say equals. Now watch what happens when I type book, open paren. Notice that first completion that pops up here says title, author, and page count. So what's awesome about this is that it's automatically given us an initializer for the structure, and it's given us the name notation for all the parameters. So if I hit enter, now it's asking for title. So here we could type in Cosmos. I tab over to author, which is now this array. So I can say Carl Sagan. And we can go over here to page count and we can say 485. Whoop, 485. And we have now created our first book. And it is the variable Cosmos. So let's try this out by printing some values. So if I were to say print Cosmos dot, and notice when I say dot here, it knows what the properties are of the struct book and gives me those choices right here to pick from. So the one I want is title, so I'll just arrow down here to title, and I'm done. So now I'm going to print the title. So let's try this. If I click play here, come down, sure enough, Cosmos is what is printed. And let's just do two more. So if I say print Cosmos.author, now in this case, it's going to print the array because I didn't give it an index. So if I hit play now, I get Cosmos and then I get Carl Sagan. If I went in here to author and said 0, it should just give me Carl. And sure enough, I just get Carl. And then finally, I can say print Cosmos.page count, and we can hit play on that, and we get 485. So this is a struct, and this is how we can create a new type and then use it in our code in a really structured and convenient way. So now that we've declared one book, really to do this right, we are going to need 3 books, right? So we had 3 books that we were going to put in our bookshelf, and that's what we were going to print out. At least that's what those examples showed initially. We only have 1 book here. So how do you think we would declare 3 books? So hopefully the thought would be an array of 3 books, and every element of the array is not an int, it's not a string, it's a book. So for example, right here, I could say var mybooks is going to be colon array of book. And I now have a new variable called mybooks, which is an array of books. So we've already had this var Cosmos. So one way to do this would be, well, let's declare a second variable, and we're going to call this one origin. So this was titled origin, let's see, the origin of species. And this was by Charles Darwin. And I'm just going to make up a page count here of really probably 2,345 pages, probably a very big book. And let's do one more. And we will say this is time. And then this was a brief history of time. And this was by Stephen Hawking. And I'm just going to make up this number that we used in our example of 372. And now I have declared basically 3 books here. And then I have an array to hold all my books. So what I can do is I can come over here and I can say my books equals the array of Cosmos, comma, origin, comma, time. And I now have created this array, and each element of the array is valid because they are all of type book, and my books was said to be of an array of books. So let's do the for loop. So we're going to say for index in 0 to mybooks.count. So inside our for loop, let's do a print, and let's print out title, colon, and then let's go add in our mybooks index, And then once we've referred to one of the indexes, we're looking at a single book, then we can say .title. And notice how smart the compiler is. It's actually looking through and saying, well, it's an array of books. You've got a specific book because you've indexed into the array into a specific element in the array. And now you have various properties on the book itself. So we can say title, and we don't have any compiler errors when we run it. We see that we get title and we get the 3 titles. And we could do this again now for the other attributes. So I could copy this here and we could say author. And here we're going to say author, and we'll let that be an array that it'll print out both names. And then pages. And here it is page count. And we run it. And sure enough, we've printed everything. Now this is really nice because it's a very safe way to record your data. There's no separate arrays that can get out of whack and really cause a lot of bugs. In this kind of context, you want to use a struct. So let's jump back to the slides and see if we can even improve this code a little more. So here's the slide. Here's the code that we have. And the question is, do you think we can do better? So that's a question for the students. Again, I would break up into teams, see if anybody can come up with an answer to that. So it turns out there is a better solution. It's not the perfect solution yet, but it's an improvement. So if we look at the slides here, what we see is that we have the author that was basically this array of strings. And it kind of works for first name and last name, but we've looked at this before where we want to add in more aspects of somebody's name, and it may be different for different authors. This array is not going to hold up very well. So what we could do is a dictionary. So a dictionary is a better solution here. And elements of somebody's name, we could argue, are always strings. So now we have a dictionary which has a key. Remember, virtually all dictionaries, the keys are strings, but the value can be any value we want as long as it's consistent. So this is string, so that's good. And then when we initialize our author here, we actually initialize it with a key of first name, Carl, and a key of last name, Sagan. And that's actually better because this is much clearer what we're doing. And in fact, when we go down to actually print this, instead of printing cosmos.author at 0, which is when you read that, it's like, well, what's at 0? We don't have that anymore. We say cosmos author first name. And so that gives us our first name back, and it reads very clear in the code. So the next question is, can we do even better? So again, I'd open that up for the students, see what they think. So it turns out that that author can be a struct, and that would be the best. And so what we do is we declare a struct called author. Notice the A is capitalized, and we have the components first name and last name. And then down here in book, we actually have the author is of type author. So it is of this struct type. So in this scenario, when we initialize Cosmos, we're initializing it to the struct book. Here are the properties that are getting initialized. One of those properties happens to be another struct. So here is the initializer for that struct. And that struct has first name and last name, which are the properties that we have here of this struct. So when we come down to print this, we can say print cosmos dot property of the book, author, property of author dot first name, and our code reads really well. And this is very safe, and this would be considered the best solution. So that's structures. What we did is we talked about what a structure is. We talked about why we need them. We've talked about how we declare them, and we've talked about how we operate on structures.